Hello guys, welcome to my new YouTube channel, the M.A.P Education. So, today we are going to study the first lesson of your chemistry, the solid state. So, you have total 8 marks weightage from this lesson. If you study with me, I assure you that you can all get all that 8 marks with you. So, you have one MCQ, one 2 marker and one 5 marker. So, in total you have 8 marks. So, you can fetch all the 8 marks if you study with me. I'm repeating this sentence. So let's move on. I have written some synopsis. With the help of this synopsis, you can get all the 2 markers and 1 markers. And I have made a separate section for 3 markers. So let's move on. Get ready, start and move on. So we have solids. Solid is being classified into 2 types. One is crystalline and another is amorphous. So under crystalline, we have the properties of crystalline listed here. Regular arrangement, sharp melting point, and it is anisotropy. What do you mean by anisotropy? The physical properties like conductivity, refractive index remains different in different direction. It remains different in different direction. Whereas in amorphous we have the properties like it's irregular in arrangement. It is not having a sharp melting point. It is isotropic in nature. So what do you mean by isotropic? The physical properties like refractive index, conductivity remain same in all the direction. If you measure from any direction, the properties remain same. Whereas in crystalline, if you measure the physical properties, it remains different in different direction. That's the difference between crystalline and amorphous. So now we have types of crystalline solids. We have ionic, covalent, metallic and molecular solids. So I have written some definitions. These are for your MCQ point of view. So like you have the definition of lattice point. So what is a lattice point? Each point in a crystal system is called lattice point. So we have the definition of crystal lattice. What is a crystal lattice? A regular arrangement of atoms or ions or molecules in a 3D space is called crystal lattice. So I have definition for unit cell. What is a unit cell? Smallest portion of space lattice which is repeated in 3D space is known as unit cell. So we have the different classification of unit cell: SCC, BCC and FCC. In SCC, the constituent particle, that is lattice point, present only at the corners. In BCC, the constituent particles lattice point present at the corner plus one lattice point present at the center of the structure. In FCC, the constant particles are present at the corner plus one particle at the center of each faces. At the center of each faces in a cube, you have 6 faces. So at the center of each 6 faces, it have one constant particles. So now let's move on. This is an important 2 markers. So they can ask you, write the number of atoms or particles present per unit cell in SCC. So for that you have this, what I have written it below, that contribution of each particle of unit cell is 1 by 8. For an vertices, for a point at the corners, its contribution is 1 by 8. So how many vertices are there? Totally there are 8 vertices. So if you multiply 1 by 8 into 8, you get the answer 1. So this is the number of atoms or particles present in SCC. Because here constant particles are present only at the corner, so the number of atoms will be 1. So in BCC, like the constant particles are present at the corner. So constant particles are present at the corner means we can take the value of SCC. SCC is 1. 1 plus 1 particle present at the center. So 1 plus 1, it's 2. So the value is 2. So in FCC, the number of particles per unit cell. So like in FCC, the constant particles or lattice point, whatever you want to call, is present at the corners plus at the center of each 6 faces. At the center of each 6 faces. So the contribution of corner particle is 1 by 8 into number of vertices. There are 8 vertices. So if you cancel, you will get 1. So contribution of particles in FCC crystal is 1 by 2 into 6 faces. I am saying at the center of each 6 faces means 1 by 2 its contribution. 1 by 2 into 6 is 3. So if you add this both, so 1 plus 3 you get answer 4. That's it. This is important 3 markers. Not 3 markers, it's 2 marker. So let's move on to coordination number. They can ask you, What is coordination number? So number of particles which are directly attached to the given particle is known as coordination number. So like they can ask you what's the coordination number in SCC. This will be an MCQ. Like you can get 2, 4, 6, 8 some values, but the coordination number in SCC is 6. In BCC it's 8 and in CCP it's 12. What is CCP? Cubic close packed structure. Cubic close packed structure is known as CCP. In that the coordination number is 12. Now let's move on to voids. There are two types of voids. What do you mean by voids? Void means an empty space. So we have two types of void. One is tetrahedral and another is octahedral. So what is tetrahedral void? It is an empty space which is surrounded by 4 sphere. Octahedral, empty space surrounded by 6 sphere. So in tetrahedral void, the number of voids can be 2 in a cube structure. In octahedral void, the number of octahedral void in a cubic structure can be 1. So we have defects. There are many defects which I have listed it below. Like first one you have point defect. It is a defect which arises due to irregularities in arrangement of atoms or ions. Second is line defect. It is the defect which arises due to irregularities in arrangement of atoms or ions in the entire row. This is same as point defect, but an extra point is that it is present in the entire row, and this point defect is present at the particular point only, and this line in the entire row. So now we have vacancy defect. It is the defect which arises due to the missing of certain lattice point, due to the missing of certain lattice point from the crystal lattice. I have given the definition of lattice point as well as the crystal lattice. You can refer the above PDF. Interstitial defect means the defect which arises due to the displacement of smaller ions in interstitial sites. Interstitial sites are the sites which are empty. It is the most important question. What is the difference between Schottky and Frenkel defect? Schottky defect. Schottky defect, it is the missing of equal number of cations and anions from crystal lattice. And Frenkel defect, if the smaller cations are occupying the interstitial position, is known as Frenkel. So what happens in Schottky? The density decreases, whereas in Frenkel there is no change in density. In Schottky, the cations and anions are similar in size, whereas in Frenkel, the cations and anions are having different size. So important question, what is F center? It is asked in MCQ as well as the 2 markers. Important question. The anionic vacancies occupied by unpaired electrons are known as F center. The most important question, which is repeating from past 3 years or 4 years. The anionic vacancies which are occupied by unpaired electrons are known as F centers. So now you have impurity defect. The defect in the solid which can be introduced by adding impurity is known as impurity defect. Now we have about the semiconductor. Like semiconductor, you know that semiconductor is a solid or a metal which is having a properties like conductivity and resistivity values between conductor as well as insulator. So you have two types of semiconductor. One is intrinsic and another is an extrinsic. Intrinsic means a semiconductor in its purest form. And extrinsic semiconductor means semiconductor doped with an impurity. So you have two types of extrinsic semiconductor, and this is also an important question. One is N-type and another is P-type. So N-type, it is like 4 valence electrons of silicon atoms are doped with an pentavalent impurity. If you dope an pentavalent impurity with silicon, one extra electron remains mobile, so it is ready for conduction. Whereas in P-type, the 4 valence electron of silicon are doped with an trivalent impurity. Here majority carriers are whole, whereas in N-type the majority carriers are electrons. So you have some example for pentavalent impurity are like phosphorus and arsenic. Trivalent impurity, it's boron and aluminium. So we have now most important 3 marker questions. They can ask you packing efficiency in SCC, packing efficiency in BCC, packing efficiency in FCC. So you know the formula for packing efficiency. It's number of particle into volume of sphere by volume of cube. So number of particle in SCC it's 1, in BCC it's 2, and in FCC it's 4. That we know. Volume of sphere we know that it's 4 by 3 pi r cube, which we have studied in earlier classes. Volume of cube also we know it's a cube, but we need to find the value of a cube. So we know that a is equal to twice of radius. According to this diagram, we can say this a is equal to twice of radius. So a cube will be 8r cube. If you substitute all these values and you can cancel this r cube and r cube, you get the value as 52.33%. Now we have packing efficiency in BCC. BCC formula is number of particles into volume of sphere by volume of cube into 100. This also you get in percentage. So I said that the number of particle in BCC it remains 2 and volume of sphere is 4 by 3 pi r cube. And volume of cube, this is the only thing which we need to find in each and every packing efficiency, volume of cube. So you should remember one thing. For SCC, A is equal to 2R, and for BCC and FCC, it's different. It's not the same. For BCC, you should consider a triangle in which the hypotenuse is 4R. Like you have a one radius, and in the center you have the twice of radius, that's diameter. So the hypotenuse is 4R, and the another side this is opposite, which is 2a, and the adjacent is a. If you apply Pythagoras theorem, you can get the value of a is equal to under root 16r square by 3, and the value of a cube will be 64r cube by 3 under root 3. So if you substitute all the values here, you get 68%. They can ask you what's the packing efficiency in FCC. We know the packing efficiency formula is number of particle in FCC into volume of sphere by volume of cube into 100. So what we have to find is volume of cube. You can analyze this diagram with previous BCC. Everything is same except the opposite. There it was 2a, here it's a. You can put Pythagoras and this hypotenuse is 4r. You can put Pythagoras and you can get the value of a. A is 2 under root r and a cube is 16 under root 2 r cube. If you substitute all the values, you get 74%. Now the most important numerical questions can be calculate the density. So you know the density formula is Z into M by Avogadro's number into A cube. So what is A cube? A cube is volume of unit cell or volume of cube, where A is equal to edge length and Z is equal to number of particles in SCC, FCC, BCC. In case of SCC it's 1, BCC it's 2 and FCC is 4. And M is mass and Na is Avogadro's number, which is 6.022 into 10 power 23. Now I have given a small numerical question. Like this, the question can come for your board exam. Question is the calcium metal crystallizes in FCC lattice with edge length 3.608 into 10 raised minus 8 centimeter. Calculate the density. And the atomic mass of calcium is 40 gram per mole and the Avogadro's number is 6.022 into 10 power 23, which is the hint which I have given. Read the question twice, analyze whatever it's given in the question and think what we have to find and substitute the formula. The solution for the given question is density is equal to Z into M by A cube into Avogadro's number. We know that Z is number of particles per unit cell in FCC, it's 4. And M is mass. Mass of calcium is 40. We know that very well. From 8th standard we are studying that. And what's A cube? A cube is volume of unit cell or volume of cube, where A is equal to edge length. Edge length is given in the question. So edge length is 3.608 into 10 raised minus 8. So A cube will be 3.608 into 10 raised minus 8 to the whole power 3. And Avogadro's number, we know that it's 6.022 into 10 power 23. So substitute in the formula 4 into 40 by 3.608 into 10 raised minus 8 to the power 3 into 6.022 into 10 power 23. You can use normal calculator for the calculation. Like in the numerator we get 160 by denominator 282.79 into 10 raised minus 1. So that 10 raised minus 1 goes on the numerator, the negative becomes positive. So 160 into 10 by 282.79. So if you divide this, you get the value for density is 5.657. That's it. Thank you so much. If you studied this, whatever I've taught you in this video, you can fetch 8 marks. You can fetch 8 marks. Thank you.